For this activity, I will explain how my Arduino program and circuit perform the required functions stated. When the Arduino program starts, all 12 LEDs are initially turned off. This is done in the setup function, where each LED pin is configured as an output and explicitly set to low. This ensures that no LED lights up unintentionally when power is applied or when the program is reset. While the tap switch is pressed, the program allows the LED sequence to run. The button is configured as active low. So when it is pressed, the Arduino detects a low signal and enables the animation. At this point, the LEDs follow the program sequence pattern, which continues to update at a fixed time interval. When the tap switch is released, the program immediately pauses the LED movement. The current state of the LED is frozen, meaning no LEDs turn on or off while the tap switch is not pressed. This pause is achieved by preventing the animation update function from running unless the button is actively pressed. When the tap switch is pressed again, the LED sequence resumes from exactly where it stopped. The program does not reset the LED positions or counters, allowing the animation to continue smoothly from the previous state. This section defines the hardware pin connections. LED count specifies that there are 12 LEDs used in the circuit. The array LED pin stores the Arduino pin numbers where each LED is connected. The button pin is assigned to pin 0. It is configured as active low, which means the button reads low when pressed and high when released. This section defines the two operating modes of the program using an enum. Mode stack means LEDs are stacked using a walking LED effect. Mode drain means LEDs are turned off one by one. The program starts in mode stack by default. These variables control the LED animation behavior. Walker pause tracks the position of the moving LED. Stack count keeps count of how many LEDs are already stacked. Drain index determines which LED will turn off during drain mode. These variables manage the timing of the animation. Step delay sets a delay of 80 milliseconds between animation steps. Last step records the last time the LEDs were updated. This variable determines whether the animation should run. The animation only operates while the button is pressed. The setup function runs once when the Arduino starts. All LED pins are configured as outputs and initially turned off. The button pin is set to input pull-up, enabling the internal pull-up resistor so the input reads high when the button is not pressed. The loop function runs continuously. It first checks if the button is pressed. If the button is pressed and the delay time has elapsed, the program updates the LED pattern by calling update pattern. This function selects which LED animation to execute. If the current mode is stacking, stack mode is called. Otherwise, the program runs drain mode. This part means that all LEDs are first turned off to reset the display before updating the animation. This part turns on the already stacked LEDs starting from the rightmost LED. The walking LED moves from left to right until it reaches the last available unstacked position. When the walking LED reaches the last free LED, it locks in place and becomes part of the stack. When all LEDs are stacked, the program switches to drain mode. In drain mode, LEDs are turned off one by one, starting from the leftmost LED. Once all LEDs are turned off, the program resets the variables and returns to stacking mode. This Arduino program demonstrates a two-state LED animation controlled by a push button. The LEDs first stack from right to left using a walking LED effect, then drain from left to right. The cycle repeats as long as the button is pressed.